Okay, hello, welcome back to one of my video log recording sessions. Today, or rather tonight, we're going to cover the Jupyter notebook titled Genetic Algorithm Grid Search 340 Items Comb FX, as in a combination of functions, revised. I'm sure I've done the same notebook before, almost the same notebook before, but this, like many of my previous few videos, this is a revised version where I used, the new metric, the average of top something percent entities in terms of summed utility values. So the difference here in this notebook is that I've introduced a few measures to actually be able to see and calculate changes in the results whenever I change the the functions for the procreate part. And in this notebook I am going to be demonstrating in each step. It's like this: 0, 1, 2, 3. In each step here, demonstrate the evolution, which would use a combination of procreate functions. So it's not just going to be one procreate function that is used. It will be two in this notebook. So for example, it's going to be the Lonely Island plus the Monopoly Elitist combined, switching from one to the other after some generations, or maybe even randomly, maybe also not maybe, and also randomly selecting which procreate function to use for that generation. So without further ado, I will get started. So the rest of them, or most of the notebook, most of the contents in this notebook are the same, except the part where I added the compute average summed utility function. And here are the hyperparameters. The population size is 1000, and we have 40 items, and therefore the number of items is 40, and the mutation rate is 3% per gene, and the crossover rate is 0.7, but again, I'm not actually using that. I'm not directly using that. Certain aspects or certain things that require this are kind of implemented organically within the code. For example, in one of these in one of these functions. So I will initiate Genesis and play the evolution out. I create the void genes, I create the Genesis 0 and stuff like that, and I'm just going to create a list, or rather 4 lists, namely peak list, plateau list, dip size list, and dip percentage list, and these are going to be empty. And what I'll be doing here is that at the end of each step I will calculate the peaks. I'll decipher the peaks and get the average of those peaks. Also decipher the plateau level, or rather plateau levels, and get the average of these values. And I will subtract the average plateau from the average peak, which would give us the size of the dip. And I'll also calculate the dip percentage by dividing the size of the dip size by the average peak, and all those values will be stored in these four lists, empty lists, at the end of each assessment, or at the start of each assessment rather. So the first one, 0, is where we evolve with only mutation. There are no procreate functions used here. So I'm just evolving, I'm just mutating things and see where that goes. And this is how it went. In this case, the maximum ever was 1045. Just keep in mind that the maximum ever is 1135. So doesn't look that bad, but when we look here, 1045, and this is the distribution of the last iteration of the evolution, distribution of the entities after the last iteration of the evolution. I evolve it 5 times each, 5 times per one of these steps, and here are the top lists, and the average peak is 800, and the average plateau level is 782. And when we plot that out, this is the plot for the heads, so not that great. Maximum ever being 1135. No, I mean maximum ever being 1045. That's, so this is where I hit that maximum ever entity. So, and because these lines are for the top entities, they oscillate a lot, like we've seen many times. And I've also forgot to mention that. Oh wait, yeah, no, I didn't. That's the next one. That's the next step. Oh yeah. So here are the plots for the top 10%, the average of top 10%, and you can see that the sum utility values just go up and then plateaus at around 800, like we've said. No, rather 782, and the average peak is 800. But we can say there's almost no dip, because the dip size is only 17, and the percentage in change, the dip percentage in change, is only 2.2%. And next up is we evolve the entities by using the monopoly elitist first, and then switch to Lonely Island. For example, in this instance, we switch after generation 80, and here are the results. Yeah, so you can see that there are a lot of well, not that much, but yeah, still there are more entities towards the right with higher average sum utility values, with higher sum utility values, and we calculate the average peak, which is 940, average plateau is 874, and here are the heads. So because we used Lonely Island towards the end, since generation 81, you can see that the top entities still get to survive. The entity that remained here will be this one, or could be this one. But anyway, that's that, and the oscillations aren't that big, aren't that wide. And you can see here that somehow at 80 is when the top entity started going up. And also with the monopoly elitist, it did peak kind of first, and then it fell down, and then only when we used the self-replicate function or the lonely island did these values go up. But that's also because these values are for the top entities, not the average of top 10%. That's this plot here, right here. But here the same is also shown, as we can see that the first procreate function, being monopoly elitist, did achieve that peak, that initial peak, and maybe the peak that never got, that never got, I don't know, it never recovered. So if you look here, it peaks at around before generation 50, or around generation 50, and then it falls down, and then it goes back up, only because we use monopoly elitist and we are preserving the top entity or top entities. So that's just weird. Yeah. Okay, so that's that. So the average peak is 940, average plateau is 874, dip size is 65, and dip percentage is 6.9%. Okay, bigger than 2, but which means that there is some sort of a dip. Next up is evolving by Lonely Island and then Monopoly Elitist. So the opposite of what we did in step 1. Again, may I remind you that step 0 is evolving with only mutation. Step 1 is first by Monopoly Elitist and then Lonely Island. Step 2 is by Lonely Island and then Monopoly Elitist. So we start the evolution, and we start by using the Monopoly Elitist first, and then switch it after generation 80. So from generation 81 we start using the Monopoly Elitist. This is wrong, by the way. These two comments should be swapped in place. They just swap places. So like this, it's supposed to be 1 and 0 in step 1, and these comments are right. Here is supposed to be 0 and 1. This is right. These comments are wrong. I'm just not going to edit it here, since these files are only. I'd like to keep these files only for demonstration purposes. So switch procreate function after generation 80, and here is the assessment. Nice bell curve. The average peak is 965. Average plateau level is 818, and here are the results for the heads. Very similar, but we do see the dip, and there are still oscillations because we keep losing the top entities due to mutation and going over the threshold. And here are the plots for the top 10%. Yeah, funnily enough, what we see here is kind of odd, because the Lonely Island does lead to some kind of more rapid evolution or improvement, as you can see here, or not. Yeah, as you can see here, but if you look at this, almost as soon as we change to Monopoly Elitist, the average sum utility value of the top 10% skyrockets and then peaks, but sadly it comes back down and plateaus. Maybe one good thing would be to Yeah, maybe not. I'll think about it. So average peak 965, average plateau 818, dip size 147, and dip percentage is 15%. Yeah, don't worry if you cannot remember these values, because we, I've saved those to those 4 lists that I created before these. What I mean is these. So they'll all be plotted too. So don't worry about that. Yep. Next one is step 3. The 4th step is evolve by randomly choosing from Monopoly Elitist and Lonely Island. So just random. And when we do that, the average peak is 945. The average plateau is 838, which is higher. And when we look at it, the result head, yeah, there's a slightly less oscillation, but still bigger than when we just use Lonely Island or towards the end. That's what I mean. And here are the plots for the top 10%. There we go, and we've seen that, and the dip size is 106, and the dip percentage is 11.23%. So that's a bit smaller. It's still a 10% decrease. By the way, the dip size and the dip percentage will get larger if there are more items. Step 4 is evolve by randomly choosing from all procreate functions. So kind of similar, but we're choosing from all 10 10 procreate functions. And here's the distribution. The average peak is 855, so lower. The average peak here is just about the same as the average plateau level of these 2 previous ones. And the average plateau in this case is 801. Here are the plots for the top entities, the heads, a lot of oscillation. And here is the plot for all the top 10% values, average of top 10%. And we see that the dip size in the average peak, so the average peak minus average plateau is 53.88 something, and dip percentage is 6.29. So there is still a bit of a dip, but smaller than these 2 or 3. However, this is due to the fact that the dip is smaller because it never actually peaked to the fullest potential, or to near fullest potential. And the 5th one, step 5, is evolve by oligopoly and then Lonely Island. So we evolve it by matching entities within the top 10%, and after probably in this case again generation 80, the procreate function is switched to Lonely Island, or the self-replicating one. And we do that. There we go. So average peak is 951. The average plateau is 874. And here are the heads. So again, this is expected. And here are the plots for the top 10%. Average peak is here, and the dip size is 76.73. Dip percentage is 8%. So this is decent. The dip percentage is smaller than 10. Yeah. So I guess this is one of the okay ones, but again, many meanings to the word okay, and something that is okay may not be okay in some other under some other circumstances. You know, if some conditions change, and we don't know how conditions will change or not, and to what extent they'll change. So something good right now isn't necessarily always good in some other cases. Whatever. Yeah, I've ranted about this some time ago. again, but still 8 is smaller than 11, so that's something to take note of. Step 6 is evolve by Lonely Island and then Oligopoly, and add the procreate function, change that generation 80. Here are the plots for the heads. So a lot of oscillation, and this is expected because we are losing information because we switched the procreate function. Here are the plots for the top 10%. Again, a huge leap upwards, a huge leap. Almost just as soon as we changed it to oligopoly, and then sadly we fall back down, only to plateau. Yeah. I don't know. Let's have a look there. Yeah. Okay. I'm just having a look at when they actually peak, and I've had countless numbers of looks at it, but it's just sometimes some things are just not that clear. But okay, so the average peak is 987, average plateau is 819, dip size is 168, dip percentage is 17.04%. So quite a huge dip percentage and dip size. Step 7 is evolving by randomly choosing from Oligopoly and Lonely Island. So again, just choose. Within each generation, choose which procreate function we'll use. And here are the plots for the heads. Somehow we got really unlucky there. By the way, the red line at the 1000 mark is just arbitrary. I just put it there because I just wanted to show or see where 1000 is more clearly. Here are the plots for the top 10%. Yeah, in this case generation 80 doesn't have that much of a meaning. However, we do peak regardless of what procreate function we use, and then we fall back down only to plateau. And in this case the dip size is 119 and dip percentage is 12. So 12% is still smaller than what, 18% was it? But 12 is still bigger than 9. We'll see. Step 9 is evolve by randomly choosing from oligopoly and opposites attract. So the purpose of doing this, to elaborate a bit, to explain for a bit, the purpose of doing this was to let the oligopoly procreate function evolve the entities so that they peak, and then the reason that we lose information, the reason that kind of information about what used to be the top entities are lost, is due to mutation. And over the generations, the top entities of the past and the information that the precious information that they held are lost, because as the generations go on, more entities that are more similar to each other remain at the top or around the top, and if they keep mating within themselves, in a way there's no innovation. I'm not speaking metaphorically, there's no innovation in terms of genes and in terms of the results of procreation, and you always have to just rely on pure luck. through mutation, which rarely ever happens. So one way to solve that, I thought, would be to use the opposites attract procreate function. Have the top entities kind of. I don't know if I'm actually doing that, but anyway. Parent 1. Yeah, because I also did that. But in this case, use the opposites attract to kind of partially populate the pool with entities with high summed utility values, and choose randomly from that pool of entities 2 entities that are different. I don't know if I just said that in a way that people would understand, but that's what I'm trying to do. So by doing that, we may be able to create or encourage some form of innovation within a generation, or maybe within 5 generations or 10 generations, I don't know. That was the purpose. It will need some more tweaks and improvements. I'm saying that because it didn't work. So the average peak was an 856. The average plateau was 799, so just 800. Here are the heads. So a lot of oscillation, and they're not really reaching the top. And here are the plots for the top 10%. Average peak, again, that dip size is therefore is 57.43. Dip percentage is 6.7. So not that big of a dip size and dip percentage again, but again this is due to the fact that it never actually peaked to full potential. That's the only reason. Step 10 is evolve first by oligopoly and then opposites attract. Yeah. Oh yeah, actually this is what I meant to explain. This is just by random, so sorry, I got that mixed up. I can't do so let me correct myself. Step number 9 is evolve by randomly choosing from oligopoly and opposites attract. Number 10 is using oligopoly first and then opposites attract. You know, with the intention of letting the population evolve first, and then after a certain point in the generations, after some time, have the parents be 2 different entities, two entities that are very, very different in terms of their genes, in terms of what their genes hold. So we do that, and we switch the in this case we switch the procreate function after 50, generation 50, for some reason. I don't know why I did that. I don't think it would actually matter, but I will try again. Should I try again? How long does that take? I don't know. It's gonna take 6 minutes. Maybe moving on. So here are the plots for the heads. Lots of oscillation. We never reach back up. Here are the plots for the top 10%. The peak being average peak 944, average plateau 790, and the dip percentage is 16%, 16.28%, and the dip size is 153. So, not that ideal. And step 11 is evolve by randomly choosing from oligopoly and birds of feather. This is kind of like the opposite. I introduced this function birds of feather in the hopes that maybe for innovation I'll let the mutation do the work, but I will maybe I'll let two entities that are very similar to each other, whether their scores are high or low, um, I'll let those entities mate and procreate, and maybe through that we can have the peak back up. And the result is, here's the average peak, 859. Average plateau is 800, and this is for the heads. What I hoped never happened. And these are the plots for the top 10%, and we barely ever peaked. And even when that is the case, we do still have a dip, so not that great. So moving on, which is evolve by oligopoly and then birds of feather. So we switch from first oligopoly and then to birds of feather at generation 80 in this case. Arbitrary, very, very random. In the hopes that, again, let the population evolve and then use birds of feather to have entities that are very similar to each other mate. And this is what happens. The the average peak is 934. The average plateau is 790. Here are the plots for the top entities. So not that great, because at least for the plots for the top entities, for the heads, they should go back up. There should always be some entities hitting the ceiling. It never happened. Or kind of it should have some kind of an upward slope. It never happened. It doesn't happen. So here's the plot for the top 10%, and the average peak is 934, which is this black line. Notice how the red line goes above the black line, but then again, these values are, average, so that's why. And average plateau is 790, dip size is 144, and dip percentage is 15.42%. Okay, so these values are all very hard to memorize and compare. So we move on to comparisons and use those values stored in those 4 lists that I created. Again, the red line is at 1000 for no reason, but makes it kind of easier to compare. And if you look here, and this plot is for the dip percentage. If you look here, the last 5 methods, or last 5 combinations, actually gave us somewhat very little dip percentage. 0.00 being 0% and 0.10 being 0.10 being 10%. So actually these are 2% or something. So the last 5 gave us little to no dip percentage, and the highest one being 1, 2, 3, 4, 5, 6. The 6th one had the highest dip percentage, which is evolved by Lonely Island, and then oligopoly, as we can see here, the highest, 17%. But if you look at here, the blue dots are the average peaks, the orange dots are the average plateau levels, and if these two are close, it means that the dips are small, and therefore the dip percentages are also small. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Why do I have these values? That's not wrong. No, I meant to say that's not right. My bad. I'm so bad at this. Comparisons. I'm looking at my laptop. See, I am bad at this. Oh god. So, I didn't want to do this. So here are the values. I'm just running it. 0.02 something, 0.06, 06, 0.15, 0.11, 0.06, 0.08, 0.17, 17, 0.12, 0.02, 0.06, 0.016, 0.20, 0.06, and 0.15. Is that right? Did I ever get 12? 20. Yeah, there we go. Wait, I missed this one. I missed step 8. Step 8 is where we evolve by randomly choosing from opposites, birds of feather, and pure chance. You know, I did this just for fun. And this is what happened. Very nice bell curve. Not necessarily a good thing. Average peak is at 804, and average plateau is at 787. And here are the results for the heads. Here are the results for the top 10%, and you can see that there's only, you know, a very there isn't much of a dip that we can talk about because it's only like 2.16%, 2%. So I think it's safe to say that if the dip sizes or the dip percentages are 2%, around 2%, or rather to be more exact, minus 2%, we can safely say that there isn't much of a dip, or there is no dip. So again, we go back to the comparisons because this plot is wrong, my bad. Oh no. I didn't. That's not gonna work. First, I'm gonna run this and then compare. This was that one, and dip percent list. What? No. What happened? Oh, I'm so bad. I am so bad at this. There we go. I don't want to do that. Seriously? Where? There's another one. There we go. That looks about right. So, let me just get rid of this. Now we can talk about it. these aren't exact values, but these are close, and we can see here that the dip percentages kind of vary. So what we would like actually is not necessarily from all these combinations, but come up with a combination of procreate functions that gives us quite high utility average peak and smaller dip sizes, or higher plateau levels, average plateau levels. So if the blue dot is closer to the red line and the orange dot is closer to the blue dots, that's good, which would automatically make the green dots go low, and the dip percentages also will go down. So I need that. However, for example, this one doesn't meet those needs. This one doesn't solve anything, as it means here that well, the blue dot is too far away from the red line, meaning that it never actually peaked to its fullest potential. So in this case, for example, 6. What is 6? 0, 0, 1, 2, 3, 4, 5, 6 is this one, evolved by Lonely Island and then oligopoly. Then again, the dip percentage is too big. So I'd like to make that smaller, which could result in number 5, step number 5, which is evolved by oligopoly and then Lonely Island. Yeah, I mean, that's not a bad idea. Not really that bad. Or this one, for example. What was number 1? Evolved by Monopoly Elitist and then Lonely Island. So it seems that adopting Lonely Island after, or after 1 or 2 procreate functions could lead to the preservation of the information of the top entities. But again, this is all too much guessing, rather. I still have to comb through all the entities per generation in order to be sure about this. But anyway, at least for now, that's what it looks like. But I'm sure that all the other procreate functions will have a purpose of 2. I just haven't found them yet. So that's it. Thanks for watching. That was 43 minutes. Wow. Bye.